Questions 58 through 61 deal with rate problems. So let's take a look at the first one here. Here we've got a car leaves town at the same time. Two cars leave town at the same time, going in opposite directions. One travels at 44 miles an hour, the other at 55. And they want to know in how many hours will they be 297 miles apart. So here's the situation. We've got one car going here's town. One car's going this way, one car's going the other way. Now, one car's going a little faster. See, one car's going 55, the other's going 44. Now, eventually, there'll be a total distance of 297 miles apart. And so what we're going to end up wanting to do here is call one of these distances like D. And then we call the other one the total, 297 minus D. And so when we set the problems up, their distance equals rate times by time. And we're going to use our distances that we have used here, so our expression for the distance. So like for instance, this one, 297 minus D, because D was, or 297 was a total distance, minus a unknown distance, equals the rate, and the rate of the faster car is 55. And I could have called this one 44. It doesn't really matter. And since they left at the same time, so notice the same time, they're both going to have the same unknown of t. So the other one's going to be d equals 44 times by t. And so what you're going to end up doing here is substituting. Take this 44t right here and substitute it in for that d. So rewrite the equation, 297 minus 44t equals 55t. And so all we have to do is subtract, or actually add, opposite operation here, add 44 to both sides, and that gives us our 297 equals 99t. So all you do from this point is just divide by this 99, and you'll have your answer. Well, it just so happens to go in there evenly. And so 99 goes into 297 3 times. Now that's just the time. Let's see what they wanted to know. How many hours? Yes, that's all they wanted. So 3 hours it's going to end up taking. And so the next one talks about Ted's average driving speed for a 5-hour trip is 60 miles an hour. All right, they're giving us a time and a average speed. So that's a total. So let's go ahead and write that down. Distance equals rate times by time. And they're giving us a total distance of, actually, we're going to find that out. Total time of 5 hours. The average driving speed was 60 miles an hour. We're going to multiply those two numbers, and we come up with 300. So this is a total. Total time was 5 hours. Total average speed was 60 miles an hour. Total distance is 300. During the first 3 hours, they ended up driving at an average speed of 50 miles an hour. So 50 miles an hour for the first 3 hours. So we go ahead and multiply, that makes 150. Go ahead and subtract those two numbers, and this gives us, and the remaining distance is 150 miles. And it looks like they're asking for what is the average speed for the last 2 hours. So 2 hours left, you see 3 and 2, add to make 5, the total. We're trying to find out what that average speed was. Well, we just divide by 2, and that'll give us our speed. So 2 goes into 150 75 times. There it is. 75 miles an hour is the average speed of that last 2 hours. Here's a mixture problem. So when I see mixture problems, I'm setting them up this way. I've got an amount. Of solution. And we're going to end up multiplying this by a rate. And the rate is going to be a percentage. And it's a percentage of whatever they're dealing with, in this case, salt. And so it gives us an amount of salt at the end. And so when we do this, we go ahead and come up with 2 different parts. That's what they're giving us. We're mixing these 2 parts together, and we're going to end up with a final mixture. And so let's take a look at the first part here. We've got a 30% salt solution is to be mixed with a solution containing 50%. So those are the 2 parts, because it says we're mixing those 2 parts. To make, this is the key word that tells us that we're dealing with the mix now. So to make 200 liters of a solution that's 42%. And so what we're going to end up doing is we're going to call one of these x, like this one here. This one's going to be the 200 minus x, the total minus x. You go ahead and multiply across, we get 30x here. Over on this side we get 10,000 minus 50x. And over here, 2 times 42 makes 84 with 2 zeros. And so we go ahead and add those first two parts together because the amount of salt for the two parts will equal the total amount for the mixture. And so we go ahead and do that. 30x plus 10,000 minus 50x equals 8,400. And so we do some opposite operations here. Notice how we're going to collect these two terms. They're opposite in sign. So they end up making a negative 20x. We've got to subtract that to 10,000. Now, I'm going to put the 10,000 on top, and I'm subtracting it because I need to end up actually borrowing a little bit to come up with my answer. So if you look at it, it ends up making 1,600. And so when you do that division, you end up dividing by the negative 20 on both sides. The zeros at the end cancel out, so just do 2 into 160, and we're dividing by negative 2, so the negative signs cancel. That makes 80, and it's 80 liters, I believe. Let's check our units here. It looks like L, yep, so liters. 80 liters. Now go back in your chart here. X represented the 30%, so 80 liters of 30%. To find the other one, you just put the 80 right here and subtract it from 200, and that gives us 120 liters of the 50%. Well, looking at the next problem, it's another mixture problem, and so we'll set up the same sort of chart. We've got an amount of solution. We're going to multiply that by a rate, and the rate is a percentage of salt. And so at the end, we're going to end up with an amount of salt. And so we go ahead and do some work there. And we'll also put in our parts here. So we got part 1, part 2, and our mix, our final mix all together. So we read the problem, and it talks about how many gallons of a 30% salt solution. So how many? Well, they're giving us our X already. How many of a 30% salt solution must be mixed with 60 gallons of a 13%? So 60 gallons of a 13% to obtain. So right there, that tells us now we're dealing with the mix. See, it should be mixed with 60 gallons. So I know those are the two parts. To obtain a solution that's 20%. So 20% goes down here. Now these two always add together to make the final product. So we're starting with 60 gallons and we're adding X gallons to make something that's more concentrated in salt, 20%. So we go ahead and multiply across. We've got 30X and the 60 times by the 13 here. So let's see here. That makes a 780. And then over on this side, 60 times by 20 makes 1,200. And then we have the plus 20x. So these two parts get added together. So we now have this 30x plus 780 equals 1,200 plus 20x. So you just start moving terms around. So it's all about subtracting or adding to move things from one side of the equal sign to the other side. So we'll go ahead and subtract that 780 from both sides. Make sure you borrow a bit. Change that to an 11. So we end up with a 420 equals, and then I've got to subtract this 20x from both sides. And that gives us 10x. So this is a nice problem because we just have to divide by 10. When you divide by 10, you get a 42 in this case. So 42 gallons. Then you go back in your chart, it tells you the amount. It's the 30%. So if you forget, you can always go back in the chart. That's why the chart's kind of nice. 42 gallons of a 30% is what we needed there. Well, looking at the next problem here, it talks about a car leaves an airport, drives due south at 120 miles an hour. So it's going south at 120 miles an hour. 6 hours later, a plane takes off, flies the same direction, and eventually catches up to the car. So let's go ahead and write an equation that matches this. Distance equals rate times by time. We've got the car, we've got the plane, and let's go ahead and write their equations. So eventually they'll be at the same spot, same distance. So their distances are equal. We just don't know what that is. Now their rates. Well, the car leaves the airport, going down the road pretty quick at 120 miles an hour, and we don't know the time, so let's just call it t. Now the plane takes off, flies the same direction at a much quicker rate at 480 miles an hour. And its time, well, we don't know that either, but we know it left 6 hours later. So we're going to take away 6 hours from the time the car's been driving. So now we're ready to solve. So we're going to use substitution once more. So put that 120t back in for this d here. You've now got 120t equals 480t minus, now we got to multiply 480 by both of these numbers. So when we do the 480 times by 6, we get 2880. And so now we're ready to do some opposite operations. Subtract that 480 from both sides. Make sure that when you do that, you end up having to not having to borrow, because we have the 480 goes on top when we do the subtraction, and we end up with a negative 360. So negative 360t equals negative 2880. And so when you do that division, divide by the negative 360 on both sides, you end up with your answer. See, the negative signs will now cancel, so t equals, and then we have 8. It goes in there evenly 8 times. But let's see what they wanted. How far from the airport? Far, that's distance. They want a distance. Well, let's go ahead and plug that 8 back in for this t right here and find out that distance. Distance equals 120 times by 8. Well, 12 times 8 is 96. Add a 0, there it is, 960 miles after that 8 hours. Well, last problem here. Taking a look at this one, it talks about Ted does a job in 8 hours. Ed does the same job in 12 hours. So what we want to do is find their rates. So Ted does it in 8 hours, so his rate is going to end up being 1 out of 8. He gets 1 part out of 8 parts done each hour. Well, Ed, he does the same job in 12 hours, so his rate is 1/12. So after 6 hours, he's halfway done with the job. That's 1/2. After 12 hours, he's totally done. That's 12/12. Well, a job completion, it's very similar to distance equals rate times time. It's job equals rate times time. Well, a job completion is 100%. 100%, well, that number is just 1. So if you take 1 and you set it equal to their rates, the sum of their rates, because they want to find out how long will it take them when they're working together. You're just adding their rates together, and then you'll get your time. So we've got to come up with a common denominator. If you break these down, look for the common factor. 4 goes into each number. Well, that tells you that the 8 needs a 3. That's the factor it does not have. The 12 doesn't have this extra 2, so we'll multiply it by 2. So we end up with 2/24 plus 3/24, which makes 5/24, and times by t, and this all equals 1. Well, that means the time is going to be the reciprocal of that, 24/5. You just do some simple division. 5 into 24, well, that goes in there 4 times with 4 left over. So 4 4/5 hours is what we'll end up saying that answer is. That's how long it takes them to do the job together. Well, check out more parts for more problems.